Okay, so we wrote this little script, actually 2 cells here, where we've learned ourselves how to split a column into optimally, given a single column, optimally into 2 parts, left and right, and in such a way that when we say optimal, we mean in such a way that it it minimizes the cost according to the function which we calculated. Now, let's do the following. Let's wrap what we've learned in these 2 cells into a function. So we'll keep that for a little while, and then we'll remove that code, I guess. So let's call this function split column, right? So we are able to split the column. Okay, we'll call this split function def. What do we need for this function? Well, we need x, we need y, we need x and y, and we need indices, and we need to know which column. Right, so we have x, y, we have starting indices, and then we will be able to split these indices into left and right on a given column, because x has multiple columns, right? So how are we going to do this? So let's combine these 2 functions together, right? So first, we can actually copy this whole thing. We will have to modify it, but I think we can just copy this whole thing here first. All right, that is great. Right, so here we need splits, and splits were calculated before this column, right? Here, get splits, x, idx column, right? So we can copy this here. We may need, let's just copy this whole function out of this column, right? Out of this place to here, so that we don't accidentally delete it, right? So we get splits, splits, fine. So we can calculate this, and then it seems like this should work, right? So let me see. We'll try it. If it doesn't work, we'll find problems, right? What do we return, by the way? Because in the end, we should be able to return a bunch of stuff. So I propose we return, well, we return cost, right? We return cost, we return our optimal threshold, and then why don't we return also the left frequency and left index. So we are going to return them the following way. So maybe while we were storing these here, we will store the optimal left index and right. So we will do this left IDX. So I'm just thinking, why don't we store them in something called left, all right? And this would be, or even better, why don't we call them in another variable? We'll call them node split, right? Node split, which will have a node split, and it will be a tuple. As you remember, we can define tuples like this. There will be tuple, and here we will say left IDX, left frequency, and this the second one will be right IDX, right frequency. How about that? So this should work, and then we'll return this whole thing. So that way it's actually, I'll say return, right? So this should work, I hope, and we can test it. And we can test it the following way. Remember our index in the beginning was this, right? X, IDX, and so on, right? So it seems it should work. So let's do the following. We will call this function split call, right? And X, but instead of saying IDX, we will start with all the indices of the X. So like a total data set, right? So when we start with empty cars, we start with all of them. So it's like a root node in the beginning. And our column is a cylinder in this case. Right, so let's see what happens. Oh, it didn't work. So we'll have to, there is a column called, well, not cylinder. Cylinder is our Y. The column we want to try, MPG. We played with MPG already, right? Sorry. So it's going to be MPG. It should work. Okay, seems to work. So what's going on here? Well, it seems like we split this data set into two parts. One part has only two of Cadillac and Fleetwood, and the other guy has 11, 7, 12. I don't like the split. There's something wrong with the split, I think. 11.85. So it seems like something is not, to me, it looks like something is wrong. I can't tell you why I think it's wrong, but something is wrong here. Well, for one, look at this. Our optimal cost was like this. And when we wrapped this into the function and ran it, somehow the optimal value is not optimal at all. So it's messing something up. So let's debug this thing. Okay, so what could be wrong? So I'm going to guess the main, what can be wrong here is the following. Oftentimes, when I wrap the function, like script into a function, what happens is I forget something inside the script to put into the argument of the function, and then it ends up pulling it from somewhere else, from the outside, from what I've run so far. And well, one way to test it would be, well, let's not do that, but let's just figure out what's going on here, right? So we have get splits. We got the splits. It seems like return cost min, tk min, node split, right? So it is not returning the correct cost for some reason. This function split call xy x index mpg. Well, it's Python's feature, indents. You see return is inside the loop. That's the problem, right? So return should not be inside the loop because it returns after the very first loop, a very first step of the loop. It was getting out because return was indented incorrectly. Very easy to make mistake in Python, and unfortunately Python allows this. That's one reason why I don't like actually Python that much. It allows for making these very simple silly mistakes. Now this one looks much better, 0, 6, 14, 11, 1, 0. So this split looks much better. So let's see, did we actually accomplish the lowest value? It seems we did, right? 21. Right, so this split is much better. Okay, that's great. So one thing I don't like here is the debug statement. So I don't need to print it after everything here. Let's not print it. Let's see. Okay, much succinct, right? So what happened is my answer is like my cost was 0.31, which matches this cost, right? Which I think is right. And then 21.2 is my threshold. And the rest of it is my left-hand side indices, right, which go into left-hand side, and the classes, frequency 0, 6, 14, and the other one 11, 1. Notice both of these classes, both of these splits are not pure. Remember, the pure is if all the classes are 0 except 1. But here, neither the left nor the right-hand side are pure. So basically, if we continue our algorithm, we should keep splitting it, right? So that is great. So it seems like we were able to create this function which can split a given column, right? And then while doing so, it also nicely finds the optimal values and costs and everything. Now, how about this? What if I want to, what if instead of just giving one column, I want to run through all columns and find the lowest cost? So that's what we're going to do, right? We will run it through all columns, and we should be ready to do it because our split column is a nice function which actually takes any column you give it and is able to split it. Now all we need to do is run through all the columns. So how would we do it? Let's see. So we ran just one column. That's great. Now let's test it, right? So we tested it for one column. That was great. We will say test mpg, right? We can actually use double parentheses, double quotes here. Great. Now let's run it for all columns. So how could we do it? Well, one way to do it would be the following. A loop, right? Look. Look, it was suggesting me this. AI. It was AI suggested again. Column in X column. So columns attribute of X will return obviously all columns, so I can run through all the columns. Great, and then I can actually run this split and see what happens. Let's see. So look, it ran through all the columns. Oh, that's a lot to print, right? So that's great, but I don't want all of them. So why don't we do this? Why don't I just get the cost? Right, so I will only get the cost. Right, but I don't need all of these other guys. Well, I can pull them, why not, right? Yeah, I can pull them, but I will only print cost minimum. Well, actually, why don't we call it cost? We'll call it cost, and we will call it TK. You see, again, those of you who are still new with Python, like what I call my variables can be very different from what I was sort of returning. Because see, the variables which I created inside my function are not visible from outside. And when I'm calling this function split call here, right, the only thing I know is that it's going to return me 3 values. And I can give them any name I want on the left-hand side. They don't need to match the names in my return. And as usually, actually, they shouldn't match. It actually creates more confusion if they do match, right? So it may sound very silly to you if you're proficient in Python, but for new programmers, I see this error, this confusion often in the code which you submit in your assignments. But anyhow, so this should work, right? Let's see. Great, right? So we ran every column here. And look, which cost is the lowest? So this guy is the lowest displacement. Is it surprising? It shouldn't be. Like in the beginning of this video, not this video, but of this set of video, I said what? I said displacement. I expect that displacement will be the like the most powerful feature. Why? Well, because displacement is the volume of your engine. Bigger engine likely have bigger, more cylinders. Okay. So now, okay, we were able to do it, but how do we actually get the optimal values? Right out. So instead of printing all of them, let's just print the best one. So how do we do it? We do it this way. Very similarly, right? We will have again cost minimum. Notice I'm creating this cost minimum, right? As inside this function, but they have nothing to do with it because this cost minimum inside the function lives inside the namespace of this function. No one else sees it. So I can create another variable and they have nothing to do with each other, right? So I call it cost minimum none, and then I'll use the same pattern, right? I'll say if, again, this is a suggestion from AI, right? If cost minimum is none or cost is less than cost minimum, great, right? Then I'm going to retain this cost. I'm going to retain, I don't need column, I know the column. I'm going to retain TK minimum, right? And I'll set it to TK. And I'm going to retain optimal node split. And then I will print, well, actually, I do need to remember the column. That's a good idea. call minimum is column, because I don't know which column, right? So I'll get call minimum, I'll get cost minimum, and yeah, let's look at the threshold. Let's just print everything more or less. TK, do I need node split? Let's not do node. Well, actually, why not? Let's do the node split too. Node. Minimum node split, right? So let's print it and see what happens. Right, so what we did here is the following. What is this test? Oh, test was my first line here, right? And then let's remove this test, it's confusing. Here's the output, right? So I got my column, it's going to be displacement column. That was the best column. The cost was 0.26 and the threshold 266.9. So let's see how it stacks up here. See, there's a lot of values. So let's see if we have 266. Then Mazda is smaller, right? Mazdas are all smaller. Which are bigger? So a few cars are bigger, like this Hornet is bigger. It's 8-cylinder. Oh, this guy, Duster, 8-cylinder. My dad had Duster. Okay, this guy, Mercedes. So it seems like it's pretty good separation, right? 0.26. And then, right, so if we look at the left-hand side, we have this Mazda RX, and so a smaller engine. And the bigger ones are what? Hornet, Duster, Mercedes, and so on. Right, we had left indices. Right, so it looks, and then classes. So look, on the left-hand side, we have 11 and 7. So we have 11 4-cylinders, 7 6-cylinders, 0 8-cylinders, great separation. And on the right hand side, 0 0 14. This is a very good split. In the first split, we were able to get the pure node, so we don't need to be splitting the right hand side anymore. So think of it, we are in the very beginning of our tree, right? We're in the very beginning of our tree. I mean, it's a different tree from different data set, but imagine this was our cars data set, right? In the very beginning of our tree, we made the first split, and immediately, like here, we got the pure node. Except on our case, it's on the right hand side, right? So our right hand side node ended up being pure, and the left hand side node was not pure. So we will continue splitting it. But already we accomplished a big task, right? So we were able to write the code which finds the best split among all the, using all the features available, it finds the best split. So why don't we wrap this into a function again, right? So we have the function called split column. Let's call this function split node. How do we do it? Well, let's do it this way. We will define a function. We'll call it a split node, and it'll have it should have fewer parameters, right? So because a split node, for split column, we had to provide column every time. Now we don't need to provide column. So it should have the same parameters. So this AI guessed that it's going to be node split. No, it's not node split. It is IDX, right? My initial set of indices. And then I'm going to do the following. So I will use split column inside. So it's this guess I don't like. It's not a good split guess, right? So we will do the following. We will be we got all these nodes. So let's do. We will do split split column. So we'll use the split column. Right, like this, but we will be using this. Let's just copy this part. Right, because this is the function we want to, this is the piece which we wanted to wrap into a function. So we said cost minimum, right, node splits, blah, 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 seems to be working, right? So what are we going to return? we want to return all these values, right? For now. So we'll think of a better way of doing it. So let's not do the same mistake. Let's not make the same mistake as we did before, right? So we'll return all these values. So call minimum, tk minimum, and then node split, right? So we should be able to actually just run this, and then we should be able to get the same exact result, right? Right, but we will do the following. So instead of doing this, we will be just able to call split node like this, right? So this should produce exactly the same, right? So we will say to compare. It's a test, right? So we are running a test. Okay, did we get the same result? Yeah, we had displacement at 266. Well, where is the cost? Split node, it didn't return cost, so we forgot the cost minimum. All right, so let's do it again. Now we should get the same result, right? 0.26. Displacement, right? 266, we got that, and indices are x, blah, blah, blah. Let's see, the 11.7, 11.7. So, right, so it worked, right? So we were able to create this piece of code. So now I can remove this part, right? So now I created a set of function actually, bottom up, right? So first I learned how to split any given column, right? And then I learned, first I learned how to get the split points for any given column. And then using that, I was able to split any given column. And then I wrote the split node, which takes the node and then finds the best column and best threshold to split the whole thing. And the output is follows, right? So if I run it finally, I can remove this to compare thing. All right. Great. So bottom up, we're getting upper and upper level, right? So now basically we have this code. Given any node, if I give it a node, it will be able to split it into two parts, left and right hand side. So it's a little bit awkward sort of outputs and returns. So we will now learn the following. Now that we know how to split any given node, we need to figure out how to build the whole tree. So keep splitting or stop and things like that, right? So we will have to create some sort of recursive procedure, recurrent procedure. Which will create the whole tree just by this one operation, branching. We have to repeatedly apply branching until there is some kind of a stoppage condition. So that will be our next task.